We have another example on the board. Again, we have connected diode and resistor in parallel. First, check the direction of the current, okay, theoretical direction of current. So again, we're using the conventional current flow, so we assume that a voltage source is going to push the current from positive terminal to negative. This is my I total, and the direction of the current is going to be exactly the same like shows the arrowhead of the diode symbol, okay? So theoretically, this diode must be on, theoretically. But before we are going to say that this is on, we're supposed to make a very simple test. So at this moment, we are going to forget about the diode and find the voltage across resistor R2. So we are going to use voltage divider formula. VR2 is equal voltage source times R2 over R1 plus R2. This is equal voltage source 6 volts times R2 300 ohms over R1 3.3 kilo plus 300 ohms. So VR2 is equal 0.5 volts. So the voltage at the resistor R2 is 0.5 volts. In order to turn on, right? In order to make the diode conducting, you're supposed to have theoretically 0.7 volts. 0.5 is not good enough to turn on the diode. So diode is going to be in the off state. Okay, it's not going to work. So current is not going to sit because this is going to behave like an open circuit because of this very low resistance. Okay, very often students try to do experiment in the lab and they keep trying and trying to measure the current going through the diode, and they're measuring 0, 0, 0, 0, and finally they ask teacher what's going on. So you're supposed to realize that the value of the resistance, right, which is in parallel with the diode, is too low. In order to make the diode working, you're supposed to increase the resistance. But at this moment, we're supposed to find everything else wherever it's missing. So we found VR2 is equal 0.5 volts, so VD is also equal 0.5 volts, right? Don't say that because the diode is not conducting, we have no voltage across of it. It's 0.5 volts, but it's not working. And Vout, okay, I forgot to add to the diagram. This is my output terminal, this is Vout, and this is my ground. Vout is the voltage between this point and ground. So this is nothing else, just the voltage across the diode, across the resistor, and we found that voltage across the resistor is equal 0.5 volts. So I have Vout is equal VD, and this is also equal to VR2. This is equal 0.5 volts. If you want to find the current which goes through the resistor R1, you're supposed to realize that this is nothing else, just the current I total. Okay, this is also equal to I R1. This is also equal to I R2. Okay, and this is found by simply dividing voltage source over R1 plus R2. We can also divide Vout over R2. We're going to get exactly the same value. Okay, because the diode is ignored, the diode is not working, so this is nothing else just the series circuit. If you want to find the current in the series circuit, you're supposed to divide voltage source by the total resistance. Voltage source is equal 6 volts, and we have resistors 3.3 kilo ohms plus 300 ohms, and my total current is equal 1.67 milliamps. So this is my total current, and basically we can say that we found everything, right? We have V out. We said that output voltage is equal to VR2, and if you want to find VR1, okay, so we can say that VR1, because we are missing, VR1 is equal voltage source minus VR2. Voltage source is equal 6 volts minus VR2 we found is equal 0.5 volts. So VR1 is equal 5.5 volts. We said that current is not going to see the diode, so the diode is behaving like an open circuit. So if the problem is asking you for ID, because this is open circuit, ID is equal 0 amps. So let's take a look what we found. We found V out, we found VR1, we found IR1, we found ID, and we found IR2. So we can say that the problem is solved.